Chapter 25, Part 2, we are going to look at paired samples again, but this time we will focus on hypothesis testing. So since we're still running a hypothesis test, we can still use phantoms. I just want to recap what those hypotheses would look like and a few formulas. So for our hypotheses, we're still going to have two of them, a null hypothesis and an alternative. Now, because we're working with paired samples, what I really care about again is the difference between the two groups, or the difference between each of the pairs. So how I'm going to write this is that mu sub d, this means the average of the differences. Now, essentially I'm starting off assuming that these two groups, or within each pair, are the same. So we're going to say that this difference should equal 0. It's always going to be 0 because we're always assuming that the two pairs, or each pair, is the same. Okay, for our alternative, we have a few options. We can show that the mean of the differences is greater than 0, or we can show that the mean of the differences, so mu sub d, is less than 0, or we can show that mu sub d is not equal to 0. Okay, the only formula that I want to talk about real quick is the formula for standard deviation. Technically what we're doing here is finding the standard deviation of our sample mean, so I'm doing x bar here, but this is for the differences, so I'm going to put sub d. You could just call that d bar as well. So we're finding the standard deviation of what we expected to happen in that sample, the differences. Okay, when I'm finding this, what I'm going to do is take the standard deviation of the differences, so s sub d, and divide it by the square root of n. Okay, now this hypothesis testing for paired samples is essentially just a one sample t-test. It's the same thing as our hypothesis testing for one sample. The main thing that we need to remember is that our sample this time, so the one sample that we're looking at, is the differences. Okay, so let's go ahead and look at an example together. Okay, example 1 says, is there a significant difference in the calories between servings of strawberry and vanilla yogurt? Based on the data shown in the table, test an appropriate hypothesis and state your conclusion. So here it gives me the different brand names and then the calories for strawberry yogurt versus vanilla. Okay, so one thing I'm noticing right away is this is definitely paired data, right? This 210 and 200 relate back to America's Choice. The 100 and 120 go back to Stonyfield Farm. So these two numbers are paired based upon that brand name. They are dependent on the brand. Okay, so we're going to go ahead and run phantoms here because it's saying test an appropriate hypothesis. Okay, my p-value again is the parameter. This is what happens in the population. Okay, I'm going to put mu here since we're still looking at means, and I'm going to put mu d since I'm looking at the differences. Okay, since we're looking at those differences, for this mu, I'm just going to say that this would be the average difference in, these are both calories, so I'm just going to say the average difference in calories. I don't know what they are, it doesn't give me a value, so I'm just looking at the difference. Okay, H stands for hypotheses, so I'm looking for my null hypothesis and my alternative. Now in my null hypothesis, I am assuming that these two groups are the same. There's nothing telling me that strawberry and vanilla should have a difference in calories, so I'm assuming they're same, meaning that their difference should be 0. So that's why I put here that this mu d, the average of the differences, is equal to 0. My alternative hypothesis, I'm going to have to think a little bit about. Okay, it's saying, is there a significant difference in the calories between strawberry and vanilla? So it's not asking me to show that strawberry is greater than vanilla or vice versa. I'm just looking for a difference. So I'm going to do a not equal to 0 here. It's been a while since we've done a two-sided test, but that's what we are looking at here. Okay, my A is my assumptions and conditions, so those are the same as we saw in that last video looking at confidence intervals. The first thing I want to do is think about randomness. Nothing in this problem is telling me that it's random, but I do think that these brands of yogurts should represent all brands of yogurt. Okay, next I'm looking for my 10% condition. I'm going to count how many I have here. 12. Okay, I don't know how many brands of yogurt there are, but I'm going to assume here that 12 brands is less than 10% of all brands of yogurt. Okay, the next condition, I'm looking for normalcy. I am going to have to use my calculator here since they give me data. So I'm going to go ahead and go to my stat edit. I'm going to type in, I'm going to clear these out first. I'm going to put strawberry into my L1, vanilla into L2. In L3 here, I'm going to find all of the differences. So in L1, I'm going to type in strawberry. Vanilla is going into L2. Go ahead and pause your video as you type those in. I'm going to pause my video as I type them in. Just press play once you have everything in your calculator. Alright, I have my data typed in here, so the next thing I'm going to do is go over to L3, scroll up until L3 is highlighted, and I'm going to tell it to find the difference by doing L1, so second 1, minus L2, so second 2. Go ahead and press enter, and it finds those differences for us. From here, we're going to make a histogram and a normal probability plot of those differences. So I'm going to second y equals histogram. Looks like I already have L3 there, so I'm good to just hit zoom 9. Ooh, not looking very normal. This looks extremely skewed. There's like a huge gap and then maybe some outliers there. Let's go ahead and make a normal probability plot, see if it looks any better. Okay, I'm not loving it. This still looks, somewhat curved, but it's all right. It's straight enough. So I'm going to say that the differences are nearly normal. Okay, 2 more conditions that I'm looking for. I need to make sure that this data is paired. This is something we thought about from the very beginning. The calorie count was paired based on the brand. So this is definitely paired data. And the last condition, I'm making sure that the differences that I have here are independent of one another. So just because America's Choice went down by 10 and then Breyer's low fat stayed the same, do I think that those differences are impacting one another? I don't think so. So I'm going to say that my differences are independent. Okay, N in Phantom stands for naming the test. Okay, in this one we do want to make sure that we're indicating that this was paired data. So I call this a paired data t-test. Still using t since I'm looking at averages, right? I'm using mu, it's talking about average here. So definitely a t-test, not a z-test. Okay, t, I'm looking at the test statistic. So this would be my d bar, the average of those differences. I haven't calculated any of those statistics yet, so I'm going to go ahead and do that next on my calculator. I'm going to stop calculate, one variable stats. Make sure that says L3. If not, you can hit second 3, it should pop up there. Frequency is blank, calculate. That gives me an average of 12.5. Standard deviation, I'm going to call SD right here, 32.51. And N, we already know, is 12 for those 12 brands. So the test statistic that I'm looking at is that 12.5. Okay, O is obtaining that p-value. Again, I need a mean and a standard deviation. So the first thing I'm going to do is find what we expected to happen in that sample. Okay, well, in the very beginning, we said that we expected the two groups to be the same. I didn't expect strawberry to be any different than vanilla, so this expected value should be 0. Again, that should match your null hypothesis. You can always go back and check. I have 0 there. I have 0 for my expected value. The next thing that I need is a standard deviation. This is the formula we talked about above. I'm going to take that standard deviation that my calculator gave me and divide by the square root of n. So 9.38. Okay, once I have a mean and standard deviation, I can go ahead and draw my model here. My mean is at 0, and my standard deviation is that 9.38. I'm dropping down at my test statistic, which was 12.5. My alternative hypothesis was not equal to, so I'm going to start with shading greater than, since this is originally greater than my mean. But I'm also going to have the same area on that left-hand side. From here, I can go ahead and change this into a t-score. So I'm going to have 12.5 minus 0 over that standard deviation. So 1.33. Okay, and from here, since it's just one sample and I know my sample size was 12, I can go ahead and use TCDF. Okay, I'm going to start with finding just this right-hand side. So in my TCDF, which is second vars, my lower bound is going to be that t-score, so 1.33. My upper bound is just a big number. Degrees of freedom, one less than the sample, so 11. 1.33, 100. So far that gives me 10.52. Again, that's only on that right-hand side. Since this was a two-sided test, remember I'm looking for both of these shaded areas, so we're going to go ahead and multiply this by 2. So that gives me a final p-value of 0.2104. Okay, we're almost there. Now that I have that p-value, I can go ahead and make a decision. So I'm going to say since 0.2104 is greater than 0.05, we fail to reject. Okay, that p-value is greater. If p is too large, then we fail to reject. So, looking back up here, okay, if I'm failing to reject the null hypothesis, it means that I'm thinking that null hypothesis is true, so I don't have any evidence to say the alternative is true. So for my statement, I'm going to say, we do not have evidence to suggest that the average difference in calories or actually I'm just going to say we don't have evidence to suggest that there is a difference in the calories. Calories, I'm going to say between strawberry and vanilla yogurt. Okay, there's a few ways that you can word this. You could go back to the wording in the problem. So we are saying, is there significant difference in calories? We could say, we do not have evidence to suggest that there is a significant difference in the calories. That would be fine as well. You could say that the average difference in calories is anything but 0. But as long as you're talking about here that we don't have any evidence to show that there's a significant difference between the two types. All right, let's go ahead and look at another example on the next page. Example 2 says a company institutes an exercise break for its workers to see if it will improve job satisfaction as measured by a questionnaire that assesses workers' satisfaction. Scores for 10 randomly selected workers before and after the implementation of the exercise program are shown in the table below. So it gives you the worker's number. They're trying to be anonymous here, so instead of just saying Soto, they're giving me the number. And then this is their job satisfaction before and after that exercise program. Okay, I want you guys to pause your video, give this problem a try. After you've tried the problem, go ahead and press play, and I will go ahead and show you my answers. All right, I'll go through my answer for example 2. For P, I said that the mu sub D is the average difference in job satisfaction. This is definitely paired data since the two values correspond back to the worker number. Hypothesis-wise, I started off with saying that the average difference is equal to 0. And then this part I think was a little tricky, that the difference is actually less than 0, which is tricky to me because I saw improve. And so at first I was like, oh, greater than. So this was my thought process with that. If I want this workout program to improve job satisfaction, that means that this after, which was in my L2, should be greater than what was in L1. So I started with that. L1 is less than L2. Then if I subtract over, I have the difference there less than 0. And that difference is exactly what I have in L3, so I do need that difference to be less than 0. Kind of a tricky one there. Okay, checking conditions. It said that the workers were randomly selected. 10% of workers, or 10 workers is definitely less than 10% of all workers. Creating my histogram and probability plot, they definitely looked somewhat normal. This was paired data, and the differences should be independent. Okay, this is a paired data t-test. Using my calculator, I found the average of the differences and the standard deviation. Again, that is coming from L3, so make sure you change your 1-bar stats to pull from L3. Okay, for O, I started with finding the expected value in the standard deviation, built a model, found a t-score, and then used TCDF to get a p-value of 0.0029. Okay, I do want to show you here that you can check your answer with your calculator again. Like we said in the beginning, we're technically just running a one-sample t-test. So when I go to stat tests, I'm going to look just for t-test here. I'm pulling from data since I have stuff typed in. My mu naught is same thing as mu sub D, so just using 0 there. Make sure you change this list to be L3 since we're looking at the differences. We're looking at L3. And then I selected less than and calculate. It's a great way to check your t-score. So they have negative 3.597, I have negative 3.60, and again, our p-values are super close. Okay, based on that p-value, I said it was less than 0.05, so we should reject H naught, which means we have evidence to suggest that the exercise break did in fact improve job satisfaction.